Hello, welcome to this calculus lesson. This is a part of a lesson in the Introduction to Limits. I'm going to take a look at a problem from our text, and it has to do with finding an average velocity. You're given a position function, and then you're asked to find the average velocity between two times. And the times are numbers, starting at usually from 1 to 4, then 1 to 3, then 1 to 2. And then part D says find the average velocity from 1 to 1 plus h. I'm going to go through all of this and show you an efficient way to do this in the calculator also, and I will do part D out as well. So for this function, what I see here that I have is my function. I'm going to put that in my calculator because I have to calculate this at 1, at 2, at 3, and at 4. So just to show you how to do a repetitive calculation using a table in the calculator, I'm going to do that. So I'm going to open my graphing calculator, and when I press y equals, I will get a screen look something like that, and I'm going to type my function. Now I've already forgotten what my function is, so let me go back. Okay, it's negative 16t squared plus 128t. So to type that, I pressed y equals, I got here, negative. Do not, when you have a leading negative, you have to use this negative sign at the bottom. You can't use the subtraction key. That's an operation. This is a sign. So negative 16t, I'll use x for now. It doesn't really matter. I'll use x in the calculator. The problem said t, x squared. And then just to make sure I'm doing this right, plus 128. It'll be x in the calculator. That you could change this to a t in the calculator, but it's not worth doing. It doesn't make any difference. So, okay, I have that in the calculator. All right, now, it'll be nice. I have to evaluate this at 1, 2, 3, and 4. So now that I have the equation typed in once, I can use a table to help me evaluate it. Now, when I use a table, when I'm dealing with limits, I like to set it up so I can type in the x value I want. So I do second, and above window it says table set, and you'll see you have these choices. You can start the table at 0, and it would go up by a step of 1. That would work for this, but in more general limit problems, you might not have equal steps. So what I'm doing here is moving the arrows down so that I get ask for the independent. X is the independent variable. I get the cursor flashing over the ask, and I hit enter. And now what's going to happen, to get to the table, I do second and above the graph. You see this table in blue, second graph. Oh, it doesn't tell me anything. That's fine. I can type in x is 1. Now my first problem was to go from 1 to 4. So I'll do x is 1 and x is 4. And remember, when you're doing this secant line, you're finding the slope. So I have 112 and 256. Let's go back to the page that had my problem. So what I have here is s of 1 was 112, and s of 4 was 256. To find the slope, I have to do s of 4 minus s of 1 divided by 4 minus 1. The difference in the function values over the difference in the independent variable that created them, and it has to be y's over x's, functions over x. Don't be in the upside down slope club. That's not a fun place to be. So I do 256 minus 112 over 3, and that will get me my answer. And 256 minus 112, just doing this, is 144. I get 144 divided by 3, and that should give me 48. So I get 48 for that first answer. And then if I want to find the slope between 1 and 3, so for part B, I will do s of 3 minus s of 1 over 3 minus 1. So s of 3, if I go back and look at my calculator, I'm just going to type in a 3 here. I'm going to click the button for 3, hit enter, and I get 240. And I'm going to do 2 while I'm here too. 240 and 192 will be the other two numbers I need. So for C, S of 2 equals 192. I'm going to write that down there so I don't forget. S of 3 was 140. S of 1 is still 112. I don't have to do that again. Minus 112 over 2 this time. And that should give me 14. Yeah, I get 28 over 2. That's 14. And then S of 2, 192. A lot of times students forget to finish by taking the slope. They just do the difference and then they don't. I'm sorry. S of 3 was 240. That was a bad thing there. Let me try that again. 240 minus 112. That will not be 14. That'll be 64. That makes more sense to me, actually. The 14 seemed very small. Then for S of 2, 192 minus 112 over 2 minus 1. Notice this number changes on the bottom too. And you'll get 80. 80 divided by 1 is still 80. So you get 80. Now, parts A, B, and C is straight finding a slope, finding function values and finding the slope between the 2 points you have. The x-coordinate is what you use to find the function value. The y-coordinate is what you got for the function value. Part D is a little trickier. Part D, I didn't want to do that, but I do want to erase. I'm going to erase this, all of this, I think. I don't want to clear the whole canvas. I just want to erase these things. So we'll do part D. Okay, through the magic of stopping the video and erasing, here we have a clean screen to work with. You can always go back if you missed those first 3 answers. Most students don't have trouble with those. They have trouble with this part D. So we found S of 1 already. And S of 1 was 112. And that's not going to change for part D. The problem we have is, how do we find S of 1 plus h? Well, it doesn't come out to be a number. It will be an algebraic expression that has h's in it. What you have to do is, everywhere you had a t, you have to substitute 1 plus h. You have to be really careful, though. So I had a t here. I had t squared. That becomes 1 plus h squared plus 128. And that t also becomes a 1 plus h. So I have to simplify this in order to do 1 plus h minus 112. S of 1 plus h minus s of 1, rather. So I have to do this very carefully. And the big mistake students make is right here. They do not square this properly. That's what I want to warn you about. So you want to do negative 16, and when you square 1 plus h, you do not get 1 plus h squared. That's only part of it. You have to multiply out 1 plus h times 1 plus h, and it might be helpful to you to actually write it that way. So when I do that, I get negative 16 times 1 plus 1h plus 1h. I'll get 2h in the middle plus h squared. If you don't want to miss that 2h in the middle. Plus, and I'll distribute this 128 plus 128h. Okay, so now I'm going to distribute this negative 16. I get negative 16 minus 32h minus 16h squared plus 128 plus 128h. When I group like terms, I get negative 16 plus 128 is going to give me that magic 112. So I'm going to get 112 when I combine that. I don't know why So the negative 16 and the 128 gives me a positive 112. Negative 32h plus 128h gives me 96h. So I get, those two will give me a positive 96h. And I will still have the negative 16h squared. That all is S of 1 plus h. So now I have to do S of 1 plus h minus S of 1 to get my numerator of my slope. Well, S of 1 is right here. It's 112. S of 1 plus h is down here. I can see I do 112 plus 96h minus 16h squared minus 112. I'm going to lose the 112, and I'm going to be left with 96h minus 16h squared. So that's the numerator. Now, so I get my slope of my secant line is going to be 96h minus 16h squared all over. So I had 1 plus h, gave me the first value. Mine in the other x coordinate was, so the first x is 1 plus h, the second x is 1. So I am left with an h, so I get 96h minus 16h squared all over h. That simplifies. You can factor out an h on the top. You still get 1h, and you will get 96 minus 16h. And what you see later on when you do limits is as h gets really, really small and these 2 points here get really close together, as h gets about to be 0, it turns out the slope of that secant line is 96. That's the conclusion you can draw. So I hope this helps for you to see a little bit about secant lines and slopes, and particularly how to evaluate a function at 1 plus h or x plus h or 2 plus h or whatever it is. You simply substitute for your independent variable, which was t, whatever value, whatever expression you're given to look for. In this case, it was 1 plus h. Thank you for listening, and email me your questions.